Hello guys, this is the ion exchange. Okay, so the ion exchange, the equipment is from the brand called GUNT. Okay, and the model number is CE3300. Okay, so normally the ion exchangers are basically used in water treatment for the desalination and also for softening. Okay, and we will be know the whole equipment. Okay, you can see the setup in front of you. So we have two columns basically here. So the first one is the anion exchanger and the second one is the cation exchanger. So you can see here we have already filled the resin. Okay, now shortly we'll be clamping. So in the first part we will know the basic layout of the whole equipment. Okay, and in the second part we will see how the water is being treated. Okay, so what we have to do, you can see here we have the you can see this is the flow chart, and this is the tank where first of all we have to put the experimental water which we are going to treat, or you can say it is the experimental water tank or the raw water tank which we are going to treat. And this is for the hydrochlor the HCl solution or the NaOH solution and distilled water. So basically HCl and NaOH is going to be used for the regeneration of the resin that we are going to put here after it becomes saturated with ions, okay, or the impurities or the toxins. And HCl and NaOH will be used for regeneration, and the distilled water also will be used for cleaning purposes. Okay, so here we have the cation and anion exchanger, both the columns. So they are used separately or they can be used in combination. Okay, and we have basically 4 chambers. This pump you can see is the diaphragm pump, okay, which is used to transport raw water and also for rinsing and also for passing the acid or caustic NaOH through the columns. Okay, and then we have the you saw the collecting tank for the treated water. Okay, and the continuous measurement of, you can measure the conductivity of the raw water or the hardness. Okay, and basically the flow rate, okay, the maximum flow rate which we can go using this you can see we can go till 300 ml per minute, and the maximum head here is 10 meters, and the capacity which we can treat is approximately 5 liters, and the material which it is made of is of PVC. And the flow rate which we can go from is 16 to 16 liters per hour, and the conductivity can be varied from 0 to 2000 microsiemens per centimeter, and the voltage which we can use is 230 volt, and the hertz is 250 hertz or 60 hertz. Okay, so basically the ion exchange here involves the ions from a liquid being bonded onto the surface of suitable solid. You can see the resin here, okay, onto the and the other ions that are in the liquid. Okay, and this basically enables the substance to be removed from the solutions, these resin. Okay, and the solids that take up the ions from the liquid is known as the ion exchanger. And we already saw that ion exchanger is of 2 types. This is the cation and the anion exchanger. So basically in cation exchanger, the active groups are acidic in nature, and they can exchange the positively charged ions, normally calcium, magnesium, and or sodium. Okay, and they can be double charged or they can be single charged. Okay, and in the anion exchanger, the active groups are basic in nature. Okay, and they basically can exchange the sulfate, nitrate, chloride. Okay, and basically the tiny granules which we put here is the approximate diameter of that is 1 to 3 mm. Okay, and they are loose. You can see they are a bit compacted. Okay, process is reversible. Okay, therefore with an exchanger that is partly exhausted, so still they can be taking up ions. For that we have to regenerate the ions using the acid or base solution. We'll switch on the pump. Okay, so you can see the pump is sucking up the water. Okay, and this probe is basically used for measuring the conductivity. So from now what we will do, we will vary the flow rate from this one rotometer. Okay, so you can see it's now taking up the water. Okay, So from these valves, basically we have to, so basically this is not connected now. So if we want to pass the water from here, so we have to open up. And these ports are basically for sampling. So if you want to sample the water from here or here, so you can sample the water from here.
Okay, so what actually we do for all our equipments, we do the backwashing. We say it washing, okay, rinsing, all these, there are different names for that. You remove the salt from that later on, yes? First it's charged, the salts are charged, you measure the conductivity before and after, okay? Before that, you measure the conductivity. After that, you measure the conductivity. So pure water is non-conductor, or sodium chloride. We are going to use the sodium chloride, yes? So we will use the sodium chloride, okay? We have distilled water, this is for the washing. When we put our pump probe here, this is for the, for the pressure. If you close it fully, it will not go out, the water will not blow out, you know. This is a valve, it shouldn't be closed completely, it should be open, okay? When we are using this section, anion, okay? So we will, in the beginning, we will open only this one, okay? We will open only this one. This should be closed, it's okay, it should not go there, okay? This is, you have to open it. You have to open that one as well, but you need to take the water from here, okay? You can take sample either from here or from here, from any one of these. So I will give you the sample, you need to bring the small beaker. So you see that, you can see that, the way.
Okay.
Either from here or here,
okay.
There are two valves
okay.
You can take from either, you know. So if you take it from here, what is the difference here? This is not connected from the back side.
Okay.
This one is connected on the back side. This flow meter is connected on the back side. It's going from here to here.
Okay.
And then when it's reach here, it go all the way to go up there.
Okay.
If these are closed, it will not go this side. It
okay.
will go. It will pass from here. If you close all these valves, this is closed. This is closed. If you open this one, now this is the channel.
Okay.
See, it's coming from here. Going all the way, it's go here.
Okay.
So this is, you can take it sample from here, but it is before that.
Okay.
If you take it from the top, it will pass from there.
Okay.
So this is actually what, guys, this is a problem for the connectivity, but we are not using this one, okay?
Okay.
This is not working, I mean. Okay. This one we will use it. We will use it for the connectivity. Before that,
no problem.
Connectivity of the water.
Yes.
In the beginning,
okay.
when we did it first time,
okay.
we did it already washing. We did the
okay,
washing.
fine,
we finished
fine.
the washing.
Okay.
But you know,
but still there is water. That's what
the
I'm
resin
saying.
was new.
Okay.
I don't understand.
Yeah.
The connectivity was very high, so we were passing the water all the time.
Okay.
So first 5 samples, the conductivity was very high. So after that, 6 samples, the conductivity started reducing. You know why? Because I think that, and you shall explain it right now. Because inside the resin, he is saying, did you do the back washing? If we don't do the washing, the salt is accumulated inside, yes?
Okay, okay.
So the conductivity will be higher than the normal.
Even though there is the ion exchange.
Yeah. So we will use the first part.
The value is very high, 7.20.
So
Please note down the values, please. Don't.
This is before, okay? So every minute you have to measure the. You have
it's
to write
very
it,
high.
He will help
It's
you.
very high. Please start.
But this should be closed because this is this line, okay? Until here. These are closed. This is closed. See, the one is going there. It's closed from here. It cannot go there. This is.
Can we restart? Okay.
This pump is a small pump. It has a very low flow rate. Okay, very low flow rate. Okay, it's in the liter per minute. Okay, not liter per hour. Okay.
Plus.
Continue. Huh?
Stop it. Yeah, it's very. It went up. Wait. Or maybe probe. Give us this. Take the second sample. He's dropping, right? He's giving.
How much is it? It's the same or decreasing?
I think it should little decrease, not much.
Okay, some more reading. Let us.
That is what I was suggesting. Let it pass through the system for 5 minutes, then take the first reading. Because the pipes, you never know there is contamination.
Okay, let's take.
Decrease. I mean, it's constant, right?
Increases 0.01.
I mean, it's now constant at 6.95, right?
Block it. If you blow the beaker, you throw the beaker inside the thing.
You need to be here for 1 hour, then it will be okay. Because for 5 minutes, let the system was not stabilized, and then you started taking the readings. Dr. Gulez, I think you should stop now. It's up. Wait. Keep it like this. The probe should touch.
We don't need